Today we're finding simple interest. Interest is what you have to pay. Like if you borrow money from the bank to buy a house and then you make monthly payments, well, the bank gave you money. You don't just get that money and pay the same exact amount back. You have to pay interest, and that's how the bank makes their money. So you may have to pay your monthly payment on your house of say $1,200, but $200 of that money goes to the bank to pay them back for letting you use their money every month. So interest is the amount of money charged for borrowing or using money. Simple interest is a fixed percent of the principal. It is found by using the formula I equals PRT, where P represents the principal, R represents the rate of interest, and T represents the time. The principal is the amount of money borrowed or invested, and the rate of interest is the percent charged or earned on the amount of money. So to buy a car, Jessica borrowed $15,000 for 3 years at an annual simple interest rate of 9%. How much interest will she pay if she pays the entire loan off at the end of the 3rd year? What is the total amount that she will repay? Now 9% is not a great interest rate, by the way. So we are going to first find the interest she's going to have to pay over the course of the 3 years. So we're going to use the formula I equals PRT. I is your interest, which we are looking for. P is the principal, which is how much she originally borrowed. She originally borrowed $15,000, I'm sorry. The rate at which she borrowed was 9%, but we have to use 0.09 because we can't multiply by a percent, but we can multiply by a decimal. And the time is how long she has to pay that money back to the bank, which is 3 years. Okay, so we multiply those 3 numbers and we get $4,050. So Jessica will pay $4,050 in interest. Okay, so to borrow that $15,000 and be able to buy a car, she now has to pay the bank $4,050. You can find the total amount, A, to be repaid on a loan by adding your principal to your interest. Okay? So we're going to take our principal of $15,000 plus our interest, which was $4,050, and that's going to get us our total amount, or A. And when we add those, we get $19,050. So Jessica will repay $19,050 for her car. So instead of buying a car for $15,000, she's buying a car now for $19,050 because she has to repay the bank. So that's why it's better to buy things with cash. Nancy invested $6,000 in a bond at a yearly simple interest rate of 3%. She earned $450 in interest. How long was the money invested? We're going to use the same formula, but we're going to substitute for different variables. So it tells us she earned $450 in interest. So we're going to put the $450 here. It tells us she invested $6,000. Now the principal is either how much you borrowed or how much you invested. So we're going to put $6,000 there. And at a rate of 3%. Well, we can't have 3%, but we can move the decimal over twice and have 0.03. And the problem tells us how long was the money invested, so we're looking for time, okay? So what we're going to do is we're going to bring the 450 down, and then we're going to multiply 6,000 by 0.03 and get 180, and we're going to bump that 180 right next to the t. So now we have a coefficient times a variable. So we're going to divide each side by the coefficient, which cancels these out, and 450 divided by 180 is 2.5. So the money was invested for 2.5 years, or 2 years, 6 months. John's parents deposited $1,000 into a savings account as a college fund when he was born. How much will John have in his account after 18 years at a yearly simple interest rate of 3.25%? So again, we're going to use the same formula. and we're looking for how much will be in his account. So we are going to first need to find the interest made because they deposited or invested, and then we're going to have to add the interest made to the $1,000. So the principal, or what they put in the bank, was $1,000 at a rate of 3.25%. So we need to move that over twice, and we're going to use 0.0325 for 3.25%. Okay, times our time, which they already have down there for us, of 18 years, because we're going to say, well, he graduated when he was 18. And now we're going to multiply 1,000 times 0.0325 times 18, and we're going to get $585. So now we're going to find the total, taking the principal plus the interest and getting our actual amount that we have now. So our principal was 1,000, our interest was $585, and when we add those together, we get $1,585. So, because John's parents put $1,000 in an account 18 years ago, he now has $1,585. They didn't have to do anything with that money. All they did was set it there. Okay?